welcome back to another video of Just Code It, and today we'll be solving 242 valid anagrams. So given two strings, S and T, we want to return true if T is an anagram of S and false otherwise. So looking at the first example, we see that since they all contain the same number of characters and the frequencies, we're able to return true. And for the second example, since rat and car don't have the same elements present, we will be returning false. We're given the constraints, so we see that they might not be equal, and they could be as low as 1 as the lengths. So coming to the base cases, these are questions that I typically like asking the interviewer. Constraints are typically not given to us, and so can either inputs be missing, such as can as have a word and T be empty? And for the second one, are both inputs always going to be of the same length? I know it's given to us in the constraint, but this is something that's not always given to us, especially during interviews, and something that we have to ask the interviewer ourselves. So looking at the first approach, we want to count the occurrences of each character in both strings and then compare the frequencies of the dictionaries to check if they match. The solution, the time and space complexity of the solution is both linear, big O of n, while the second solution on time is n log n, because we'll be sorting both the strings and checking if they are equal, while the space complexity remains the same. So I'd like to quickly just go over the first solution. There are two ways to actually do the first solution. First is by creating two dictionaries. In Python, we can just create default dictionary int and count 2 equals default dictionary int, right? And now for character and s, what we'd like to do is increment the count. So for that particular character that we see in s by 1, and now we can do the same thing for t. Count 2 character plus 1, and now at the very end we should be able to just check if they're equal, just like so. Let's see running it, see if it works. It does work, and it actually looks perfect. And now we'll try submitting it to see where we land among the rest of the solutions. So we place fairly in the middle. It's still relatively fast, beating out 72% of the users. These numbers vary because I've solved it before to where I've gotten to like the very front of it. And so there's actually another way to actually do this to solve this question. So we have to use counter. Counter is a method where it basically does this for us. So like it reduces the amount of lines that we have to write for code, and one of the advantages of using this in Python. So counter t, and now we should be able to return the same thing. Perfect once again, and the time and space complexity should be exactly the same. Well, this is actually places a little bit faster, but it's still the same big O of n for both space and time complexity. So now looking at the second solution. The second solution involves sorting. So one of the first things that we would like to check is actually if they are of the same length. So if as not equal to the length of t, we know that we can just immediately return false. And we'll just like to return the sorted as equals sorted t. And the space is big O of n because when we sort the list, when we do this method sorting, since we're not sorting in place, we're creating a whole new list of sorted originating from the original input. It creates extra space, and so we'll try running it and see where it gets us. So it passes all the simple test cases, and let's see where it places on the solutions. Yeah, this is significantly slower, and it says we only did 16, roughly 17% of the users. Well, thank you for joining.